Hey everybody, and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy, where we are learning networks together. And on this video, in this session, what I'm going to be going through is really more of the basics on the Juniper Junos CLI, or the command line interface. What I'm going to be going through specifically is how you actually configure the Junos VMX or VQFX or VEX routers, switches, etc. to do load balancing on those interfaces. It is actually quite a bit different to the way other vendors like Cisco actually do it. You have to configure load balancing, and there is a reason to do that. So we're going to go through how to configure load balancing, how we can actually see that going from the routing table into the forwarding table. Again, that's a difference between Juniper and other vendors. And then we're going to go into a little bit more of the basic stuff, where we're going to start talking about static routing, load balancing over static routing, aggregate routes, which is going to be very important in this architecture, and finally at the end, what are generate routes. So let's get going. And as always, here is the network for this video. As you can see, it's not complex, it is very straightforward, but that's all we need to cover the basics. Now what we have got here is an OSPF, or Open Shortest Path First network. Don't worry if you don't know what OSPF is. Down in the link box, in the text box, you could see a link to all the other videos that I've done on OSPF. But for now, all you need to know is that OSPF is an interior gateway routing protocol, which means it dynamically learns who's connected to this network, and it will advertise those routes, those prefixes, to all other connected OSPF routers on the far end of the network. And that's essentially what we're doing here. In area 1 here, we have got these networks 192.168.10.0, 10.4, 10.8, all with a /30 or .252 subnet mask. And what OSPF is doing, what I've already set it up to do, is to export these static routes really into OSPF, and they're coming into R1 here, and then R1 is advertising these learned static routes which have been exported into this routing protocol all the way over here to router R4. Now what we want to start off first with is load balancing, as you can actually see here. Then we're going to go to static routes and then generate routes, or generated routes. Now the reason why I'm starting with load balancing is because, as I said during the introduction, Junos works quite differently, as you would expect, to for other vendors' CLI or command line interfaces. So as these routes here, these 10.0, 10.4, 10.8/30 routes are advertised into the OSPF routing protocol, R1 is advertising it in this direction and over in this direction. And then routers R2 and R3 are advertising this down to router R4 and up to R4, if you look at it from R3's perspective. And as such, obviously R4 has really got two options. It can go out of the GIGI 002 interface up to R2, or it can go out the GIGI 003 interface to reach these networks here through those interfaces. But here's the but. The way Junos works is it will install these routes here in its routing table. So in the routing table, we'll see the 10.0, the 10.4 and the 10.8 network. And each one of these routes is going to be shown to have two available options. i.e. you can go out of the GIGI 002 interface, or you could go out of the GIGI 003 interface. Now that's at the routing table. However, there's another function, another table in Junos. Well, actually there's a lot of tables, but the other table is the forwarding table, or FT, or you might think of it as the packet forwarding engine. But what the RT does is it takes those learned routes in, and it makes a copy of those learned routes. So in this case, we're going to have two routes to get to the same destination via two different interfaces. But when it copies that down to the forwarding table, it's only then going to have one available interface, one egress interface, one available route. And that is because of the way the default Junos actually works. And I've just tidied up the screen a little bit just so we can actually see what I'm writing down. Now the way Junos used to work, which is the Juniper operating system, Junos, the command line interface, is it used to do something called per packet forwarding. So per packet forwarding meant that given a destination, if you're coming from this source, I am going to send you via this route, whatever that route may actually be. Now coming back to this network, what that essentially means is that R4, what it's going to be doing is it's going to be deciding based on this legacy per packet forwarding. It's going to say, well, I'm either going this way or I'm going this way. But using the per packet, what it would do is it would send every packet in one direction. So all packets are going via the same direction through, in this case, router R2. Now, whilst that might sound straightforward, and it is, but simplistic in terms of network performance, it's really not. And the reason why it's not is you might have available bandwidth in this actual direction here, and yet you're not actually utilizing it. And as such, this is known as suboptimal performance. Not suboptimal routing, but suboptimal performance. So what Junos has moved towards, so we've no longer really got per packet, what we've now got is per flow. Now, flow is really based on the different headers of the layer 3 and layer 4. So specifically what Junos will be looking at is the source and destination IP addressing plus the source and destination port addressing and some other fields as well, such as the protocol field at layer 3, identifying what is actually inside this IP payload, what is the protocol, and there's a few other values as well, and these can be configurable. And when we're actually doing this, what this actually allows is for router R4 to send a flow in this direction here, but also send a different flow in this direction here, and thus we are doing load balancing. Now, a curious thing about Junos is that even though we are absolutely doing per flow forwarding, in the Junos what you will actually see is it's actually listed as per packet. Don't ask me why it's not been updated, I really don't know. It should say per flow, but when you see me do this just in a minute, rest assured, even though it says per packet, it is per flow. So let's actually jump onto the command line interface. And here's the CLI or command line interface on router R4. Now I've just logged in, so if I just do CLI to get into the command line interface. Now if I actually just do a show OSPF route, then this will show all the learned OSPF routes, all the routes that have been learned via OSPF. And what you can see here, without going into too much detail, so I could see router R1, which is on the far end of the network, and these two adjacency routers, routers R2 and R3 here. Specifically, I can see their router LSAs. Again, if you don't know OSPF, don't sweat. There are the links down in the description box where you can get a link to all the OSPF videos I've done. But really what we're concentrating on here is these 192.168.10.0, 10.4 and 10.8/30 networks. Now, as I was saying, note here, you can see that for all these networks, there are two outgoing interfaces. For each one, we can go out of GIGI 002 or out of GIGI 003. But this is the routing table. Now, if I actually just do show route forwarding table default, then I can actually see here all the routes that have been copied and injected over from that route table into that forwarding table, and thus the Junos will know where to send packets into and out of. So if we come and focus on the 10.0, 10.4 and 10.8, you can actually see now we only have one interface for each one of these networks, whereas up above we could see there was two interfaces for each network. Now there is only one interface per network, and again that is because it is using this legacy per packet forwarding. Now we need to change it to be per flow forwarding, and the only way to do that in Junos is to actually configure a policy statement where actually you just want to take whatever it may be, a static route or another IGP routing protocol, and do some form of load balancing on that. So I've gone into configure mode just by saying configure. Now what I need to do is set policy options policy statement. I want to configure a statement, a policy statement, which will have a specific action given a certain amount of variables. But for this, all I'm going to do is give it an initial name. So I'm just going to call this LB for load balancing for short. As always, we have to give it a term, i.e. term 1, 2, 3. It doesn't have to be a number, but in my experience, it's always good to have numbers because then you can move them around and you can even inject numbers in between, i.e. 1.1, etc. But term 1. Now what I could say here is from protocol, spell it right, I could say from protocol RIP, EVPN, static, etc. Or I could do something else completely. But I'm not actually going to do that because all those routes have been learned from the other side of the network. Here we're looking at R4's routing table. We're looking at all the routes it has learned from router R1. So it really doesn't make sense to do any of this from protocol at this point. So what I'm just going to say is then, i.e. I just want to do some load balancing. So actually you can see here it says type of load balancing, which is going to go into that forwarding table. So if I say load balance and give it a question mark, we can then see, as I was saying here, it still says per packet, but it's actually using per flow instead. Hopefully this is going to be updated at some point, but this is absolutely doing per flow, i.e. taking that source destination IP address, source destination port address at layer 4, the protocol field, and quite a few other options. Those are configurable, and then we are going to export that into OSPF. So I'm going to do load balance per packet. And now if I just do show policy options, I can see that I've got it configured here. So we've got the policy statement. Now we need to configure this. We need to export that not into the protocol's OSPF. We need to actually export that into the forwarding table. So the forwarding table knows that it has the option. It can do load balancing. Now the way we do that is actually say or do the set routing options forwarding table, give it a question mark, and now you can see the export option. So if I now say export question mark, you can now see LB load balance. That is exactly what I've just configured just up here. So now if I do LB here, hit enter, and as always you have to enter the commit command. If you don't know what these edit, set, commit, etc. commands are, I've just done a video that actually shows what these are, how you can use them, the different variances of these. Again, that video is down in the description box. Now it has now completed that commit, so it's gone from that candidate database, that candidate configuration, into that running configuration. So if I do just quit, if I do show route again, we've got all the networks here, so that's great. So we know OSPF has not been impacted, and there's no reason why it should be. I can still see I've learned these routes here, and I've still got the outgoing interfaces. But remember, that's fine. It was when we came to the forwarding table that we saw that there wasn't any load balancing, i.e. 2 interfaces per network. So now if I do show route forwarding table, table defaults, then what we can now see is we've got our 3 networks here, the 192.168.10.0, 10.4 and 10.8, and now Junos knows, because I've exported that load balance per flow, it can use both GigE002, GigE003 for each one of those networks. So that is how we actually do load balancing on the Juniper Junos devices. So that's the first part done, load balancing. I did actually just realize I forgot the second part, which is actually the aggregate route. Apologies for that, but what is an aggregate route? Well, the best way to describe this is to go back into the Junos routing table itself. So back on router R4, if I just do show route here, what we can see is everything is of course looking good, but here you can actually see I've got 192.168.10.0, 10.4 and 10.8. Now an aggregate route is where we're, in my mind, we're aggregating together, we're combining these different network prefixes, these different networks, into one aggregate route. And router R1 is going to advertise that aggregate route into OSPF, and thus R4 is no longer going to see one entry for 192.168.10.0, another entry for 10.4 and another entry for 10.8. Instead it's just going to see one route, whatever that route may be. Now I'll do the calculation on that in just a second, but this is important because on a much larger network than this, imagine that you've got not 3 networks. You're not going to be bothered about doing aggregate routes because the routing table is not going to be impacted by 3 very small networks. But imagine you've got hundreds or thousands maybe on larger networks where you've got 10.4, .8, .12, .16, .20, etc., just ramplifying up. That's going to consume a lot of entries in the routing table, and thus it's going to take even longer to maybe do any type of troubleshooting or to inspect that routing table. So an aggregate route also allows the routing table to be less resources are consumed by that routing table and can actually improve troubleshooting when those times actually arise. The big thing to remember with aggregate routes though is that you have to have what is called a contributing route, which is active. Now a contributing route could be any one of these routes here. So what is this summary address or aggregate route? It's the same thing. What that is 192.168.10.0/28. Now if you know your subnet masks, you'll know that the /28 means 255.255.255.240. Now what this means in English is that each one of these routes here, so the 10.0, the 10.4 and the 10.8, these are contributing routes. Because these networks fall into this range of 192.168.10.0/28, if they're contributing, i.e. they are active, then router R1 is going to advertise this one address out, this one aggregate or one summary address out towards the network, and thus R4 will no longer see one entry and a second entry and a third entry. All it's going to see is this address here. But the big point here is that those routes have to be contributing. They all don't have to be contributing, which means alive, active. You only need one, but you need at least one contributing route for this aggregate summary address to be advertised from router R1 all the way over to R4. So this configuration has to be done on router R1. So let's go into R1 now and configure that. So I'm on the command line interface on router R1. Now we first need to define the aggregate route or that summary address. So I just know the command, so it's set routing options aggregate, really spell it right, aggregate route, then I enter in that 192.168.10.0/28, not /27. Now that is the first part, defining that aggregate or summary route, that summary address. So all those contributing routes, the 10.0, the 10.4, the 10.8 will fall inside of this. And by the way, if you don't know how to calculate that, there is a manual process to do so, or you could just go on Google and Google something like summary address calculator, enter in the values, and it will do that for you. But I do it both ways, to be honest, because you know, I'm like that. But we've defined the aggregate route, which is great. Now we need to define a policy statement which is going to take in that aggregate route and do something with it. So now we need to define policy options, policy statement, and I'm just going to call this export ag. Again, we're going to give it a term 1, and now I'm going to say from question mark, and here we're probably going to have to say from protocol aggregate. So I can't see aggregate right at the top here. I'm just scrolling down here. I do not see there's aggregate contributor, but I do not see just one for aggregate. So I'm just going to do from protocol question mark, and now we can see at the top we've got aggregate routes. So I'm going to say from aggregate, and let's do show policy options, and you can see I've already started to define my export ag policy statement. But just like we did with the load balancing statement, it's not this one here, but we defined a actual then command, didn't we? I then do something with it. I then load balance per packet. Now for the export ag, we're not going to do load balancing, of course, but we do need to, however, say then accept. I just want to accept all aggregate routes that are within this aggregate route. i.e. I just want to accept all aggregate routes. You can also make this a bit more specific and do a route filter just to look for that 192.168.10.0/28, but it's such a simple network we don't have to worry about that here. So that is the second step. So the first step is when we define the aggregate route. Second step was when we defined the policy option, which will take in that aggregate route and just accept it. And that's important because now I could do set protocols OSPF area 0 export. Oh, it's actually above that, so if I actually do export, my spelling is really terrible today, but if I now do export ag, and there you go, auto fills it for me. And if I do show protocols OSPF, we have now got our area 0, our interfaces in here, and I am exporting this legacy statement here. I can delete that, but don't worry about it. And this export ag here. In fact, I will just delete that policy statement very quickly. So if I do show protocols OSPF again, we can now see that statement is gone. So area 0 out of these two interfaces, and I'm exporting the aggregate routes. So 3 steps in summary: define the aggregate route, the address, and what you want to do with it. We're going to discard any more specific packets, whatever they may be. 2 is we need to define a policy statement, which is going to take in that aggregate route and accept it. And once we've defined that policy statement, we are going to export that into OSPF. So now if I just do a commit on this, that's now committed successfully, and after a few seconds got to allow these packets to flow to and from each other. If I go back to router R4 and just do a show route, then what you can see here is this has already happened. I no longer have the 192.168.10.0, 10.4, 10.8. I've now only got the 192.168.10.0/28. Just as before, I can go out of these two interfaces, and because I'm also doing load balancing, so if I do show route forwarding table, I can use any of these two interfaces to get to any of those contributing routes which fall within that summary address, i.e. that aggregate route itself. So that is the second part of this video, how to configure aggregate routes. So we've gone through a lot so far. We've actually gone through how to configure load balancing, as well as how to configure an aggregate route. And what we're going to go through now very quickly is how to configure static routes on the Junos command line interface. Now there's going to be 2 parts of this. We're actually going to go through how to configure a static route and how to configure a qualified static route or a qualified next hop. But in order to do this, to make this work in this architecture, what I need to do is actually something a little bit more different. What I'm going to do just very quickly is I'm actually going to enable 2 new connections between these routers here. So I'm just going to enable Gigi 004 to Gigi 004 and Gigi 005 to Gigi 005. I'm also just going to put on here the IP addressing on these interfaces just very quickly. And there we go, just done a quick addition of the IP addressing on the interfaces here. I'm not going to go through it, but you can see the Gigi 005 and Gigi 004 for both routers R1 and R4 have got their different IP addresses. That's obviously important to get any kind of IP reachability. But we need to configure those INET or IP addresses on the interface themselves. So if I just drag over my secure CRT, I've minimized this just so I can see the IP addressing because I would not remember it all off by heart. And on router R4, if I just do set interfaces Gigi 004.0 family INET address 200.10.20.21/30, and I need to do the same on the Gigi 005 interface, but this is now a .17. And there we go, that is the interfaces configured with the IP addressing on router R4. So I'll just do a commit on that, but I need to do the same on router R1. So let's do set interfaces Gigi 004.0 family INET address 200.10.20.22/30. And as before, I need to do the same on Gigi 005, but with a .18 IP address. And now if I commit this, then that is now committed. And I just want to check quickly, so if I do a ping 200.10.20.18, so I'm pinging my own interface here. We've got reachability. Can I reach the far end, which is .17, so that's router R4's interface we can. And can we ping the Gigi 004 interface on router 1, which has the IP address of .22, we can. And can we ping the remote end, which has the .21, we can. So there we go, we've got reachability between these two links going from router R4 and R1 back and forth. So in summary, what have we just done? We've just configured the INET or IP addressing on these 4 different interfaces, but that's not the static route themselves. We're going to configure the static route on router R4 because we want to say, well, if you want to get to these networks here, you can go this way up to R2, or you could go downwards to R3, or you can actually just go straight across all the way through these direct links. There might be a network in the middle, you really don't know these days, but you can take a bit more of a direct link using static routing, and that's what we are now going to configure. So let me maximize this, and there we go. So let's learn how we configure a static route. So if I do set routing options static route, that's it. Now I need to define what is that destination. So now we're going to enter in the aggregate or summary address. So I'm going to say 192.168.10.0/28. Now if I give this another question mark, we can now say, what do we want to do with this static route? Do we want to install this into the forwarding table? Do we want to resolve it if it's not directly connected? Do we want to retain it in the forwarding table if it goes down, so if it's no longer in the routing table, or do we just want to discard it completely? But here all I want to say is what is the next hop. Now I can't actually remember right now what that next hop actually is, but what I do know is we need to enter this up using the bar. So, and I just had a quick look, and it is 200.10.20.18 space 200.10.20.22 and space bar. Just to show you what those IP addresses are, those are the IP addresses of these remote interfaces here. So we're configuring the static routes on router R4 here, and we're saying if you want to get to this summary address over here that's been advertised into this network from router R1, you can go via these links here because we have defined the next hop IP address of 20.18 and 20.22. Now that is basically it. That is how we configure the static route. So if I just do a quick commit on this, and now if I just do a run show route, and what we can see for that 192.168.10.0/28 is we've now got different options. We can use OSPF routing, which is dynamic and should be preferable, or we can use the static. Note the little star here, the asterisk. That means that this has been elected to go into the forwarding table. Now out of both of these, you could see for the static route I could do my Gigi 004 or Gigi 005 interface, whereas for the OSPF I can use my Gigi 002 or Gigi 003 interfaces. But just to show you, if I do show route, if I do run show route, forwarding table, and we can actually see at the top that to go to this network we are going out of Gigi 004, Gigi 005, because right up here it has a smaller preference. As I said, static routing has a preference of 5, whereas OSPF internal has a preference of 15, external has a preference of 150. So that was how to configure a static route. But what about the qualified next hop? So let's just go into routing options. Let's do a quick show. Let's see what we're looking at here. So I've done my my export load balancing here. I've got my router ID at the top here. Now I've got my static routes here. So let's just say set static route going to that same destination of 192.168.10.0/28, but now I want to say qualified next hop. So I'm going to use one of these qualified next hops here. So I'm just going to say 200.10.20.22. I think that's the Gigi 004 interface between routers R1 and R4. Now the reason why I'm saying qualified next hop is because we can then do these extra attributes. We want to qualify as a backup almost. If you want to get to this destination via this next hop, I want to give you a smaller preference, so I'm going to give you a preference of 6. Now if I actually just do a quick show on this, it's not do commit just yet, we can actually see that we've got a static route here to go to this route via these next hops here. But for the qualified next hop of 200.10.20.22, I want that to have a preference of 6. Now if I just do a quick commit check on this and it's passed, it's commit to this. So what does all that actually mean in English? What that means is that because I've configured these static routes between routers R4 and R1 going over these interfaces here, they have this preference of 5. That beats hands down that preference internal of OSPF of 15 or 150 as we saw, because these are actually external networks at the end of the day. But 5 is smaller, has a better preference, is more trustworthy, which is why these were injected into the forwarding table. What this also means is if these links goes down, if one of these links goes down, that other link which I configured to have a preference of 6, that's standby, that's backup. So you can have one link running really hot, generating and forwarding lots of packets, and this link here is just waiting. It's just waiting to forward packets. So if this link fails, it will then drop over to the backup link, and if that link fails, we can then use OSPF, this dynamic routing protocol, to actually kick in and be installed into that forwarding table because it's already in our routing table. Or you could have actually configured that static route to have a smaller or a worse preference. So if we actually configured that static route to have a preference of say 151, we would then be preferring OSPF dynamic routing and have the static routing as backup. So now we're on to the last part. We've done load balancing, we've done aggregate route, we've gone through what is a static route and what is a qualified next route. Now we're going to finish off with what is a generate route or generated route. The best way I like to think of these is it's a static route with a specific policy. What does that actually mean in English? Well, in such a small network, obviously it's not going to mean much, but just say for example, this router up here had a connection to some kind of router which was providing cloud connectivity. That's my picture for a cloud, but it was a router which was providing BGP, just for example, or eBGP more specifically, peering. It was peering to the internet, and all external traffic which was destined for the internet, for the cloud, etc., had to go through here. In which case that router would advertise something like 0.0.0/0, maybe as a default route, it's not very specific, and that would have specific attributes assigned to it. Now those attributes in the BGP world could be quite a lot, but in the Junos coming outside of BGP, that is a huge protocol, a huge topic. Those attributes could be some kind of preference or some kind of color, whatever it may be. That is quite literally what a generated route is. In my mind, it is a static route with a specific policy attached to it. So how do you actually configure this on Junos? So let me just go into CLI mode. Let me go into configure mode. Now what I need to do here is define a policy. So let's just define a policy options, policy statement, and let's just call it BGP. Just for I do not have a BGP of BGP, and hit enter. That is then going to configure this generated route with this specific policy of BGP. Now this isn't going to mean much in terms of that policy itself, because that policy is really blank. If I just do show policy options again, you can see there's nothing really configured here. So the more you actually configure in that policy itself, the more granular you get, the more detailed you get, the more powerful this gateway of last resort, as it's known as, or this generated route is actually going to be. But that's essentially what a generated route actually is. And there we go everyone, that is the end of this video, covering a little bit more of the advanced but still at the basic level in the Junos command line interface. And we have actually gone through quite a lot. We've gone through how we actually do load balancing on the Juniper Junos devices, how it's different to what other vendors do out there, what you need to do to actually enable load balancing, whether it be OSPF, ISIS, or even static routing, what you have to do to make that work. We've also then gone into how to configure an aggregate route. What is an aggregate route? What benefits that actually brings to that routing table? Then we've actually moved on to the static route itself, how to configure a static route, and really from my point of view, in my experience, why they're a disadvantage, why you should always prefer something like OSPF, which is a dynamic routing protocol, versus something that is a static route. But nonetheless, we went through how to configure a static route and how to actually configure a qualified next hop, as we saw in the architecture. And finally, what we actually did at the end was configure those generated routes, or those gateway of last resort. So a lot of information in a short period of time, but I hope you found that useful. There's more content coming as always. Please check out my YouTube channel. I always appreciate you guys liking, subscribing, giving me comments. So if you like this video, please like it, please give me a comment. I love hearing from you guys. But other than that, thanks for watching and see you on the next time.